Okay, so in this video, we'll just go over a worked example on how to carry out a hypothesis test, right? So in the previous three parts, we talked about how we write a non-alternative hypothesis, how we calculate a test statistic, and then how we decide, if our evidence is strong enough against the null hypothesis through either the p-value approach or critical value approach. In this example, we'll just go over both approaches, right? So we'll talk about question number one over here. Right, so again, we're going back to the food tomato packs example, right? So we randomly sample 40 packs, each supposed to weigh 227 grams, and we find that the average of the 40 packs is 226.5 grams. So it's the weight in our sample evidence that the machine is not sorting right at giving an average of 227. So let's suppose the sample standard deviation is 1.5 grams. So we'll work on this question here, right? So first things first, right? We are writing the non-alternative, and I always like to write the alternative first, and we are trying to show that the average is different from the listed weight of 227 grams, right? So the null hypothesis is the hypothesis of equality. So that's the first thing we do, right? And then the next thing we have to do is calculate the test statistic. So this is a t statistic, right? Sample mean minus the null value divided by sample standard deviation over the square root of n. And all these pieces of information we have: sample mean 226.5, mu naught is 227, s over square root of n. So we are given that the sample standard deviation is 1.5, sample size 40, right? So divide by square root of 40. So our test statistic, if you evaluate this, will be the test statistic. If you work this out, and hopefully I did this correctly, this test statistic is negative 2.108. Right, so two approaches. Let's look at the p-value approach. So to find the p-value, right, we know that since it's a two-sided test, so first things first, sketch our bell-shaped curve. Test statistic is negative 2.108, so it's to the left of 0. So since it's a two-sided test, we want this area here as well as to the right of positive 2.108. So I can find this area easily by typing in pt negative 2.108. The degrees of freedom is sample size minus 1, so that's 39. And if you work this out, this should give you a probability of 0.0201. Right, so the p-value is going to be twice of this value, right, because we want the two tail ends. And if you work it out, 0.041, I believe. Oops, no, it's 0.021 here, so there's no 0 there. Right, so that's our p-value over here, which is less than your alpha of 0.05, right? So we will say we reject the null hypothesis, right? Our data supports the alternative. Our data support the claim, and you should write it in context, the claim that the population average weight of the cherry tomato packs is different from 227 grams, right? So that's basically the conclusion, right? So you should write a statement that addresses your specific question, right? Rather than just say, hey, we reject null or we fail to reject null. So what does that mean in your specific situation? I'm going to spend some time talking a little bit about this p-value of 0.041. So this p-value is telling us the following, right? If the population mean is actually 227 grams, the probability of obtaining a sample mean of 226.5 or less. So remember, right, because that represents 226.5 or less, or so the difference between this and the null is half, right? So in the other direction would be 227.5 grams or more is 0.041, right? So a p-value is saying if the null is true, right? So if the null is true means if the population means indeed 227 grams, probability of obtaining your sample result or value more extreme, that's the p-value, right? So this is where 226.5 or less, because that's more extreme, and because of the two-sided test, so we have to go in the other direction as well, so the difference was 0.5, right? So because this probability is so small, so it's basically saying your data is inconsistent with the null hypothesis, right? So that's what the p-value is measuring. So that is the p-value approach. If you want to talk about the critical value approach, just to give an example with the critical value, right? You can work it out in this way. So a critical value approach, T star, right, will be found using QT. And so let's just draw the bell-shaped curve. It's a two-sided test, right? So assuming we are doing it at alpha level of 0.05, then each of these areas must be half of that. So the middle is 0.95, right? So QT of 0.975, right? Because this corresponds to 0.95 plus 0.025 percentile. Degrees of freedom is 39. If you work this out, this critical value is 2.023, right? So the absolute value of a t statistic is over here, 2.108, which is greater than t star. Whoops, let me just write this better, right? So we reject the null, right? So notice that, and then I'm not going to write this statement over here, right? That statement I have over here in the box, we should write it over there. So you realize, right, that with either approach, the conclusions are the same, right? So the two approaches should not lead to a contradictory set of conclusions. Okay, so question number 2, right, is basically a one-sided test. How does that change? Right, the only thing that changes, right, with a one-sided test is that the p-value is no longer half of that. Critical value changes, right? For the two-side, if it's a one-sided test, your critical value would now be QT of 0.95, 39, which would have been a value of 1.685, right? So if you had done the one-sided test. So so that's the slight difference with question number 2. Okay, so that's with this specific example, right? We'll have some practice questions for you to work on, and please take some time to go over those practice questions.